Okay, so for part two, what we could do is since I generated those numbers, we can use all of the numbers I came up with.
Okay.
So it says, number 7 says randomly select 5 of the 30 salaries and compute the mean. So the numbers that I got, we're just going to need to write them down because I got, let's see, I got 16, 11, 8, 21, and 5.
Okay, so I've got those typed on my computer screen.
Nice. So yeah, now we just need to get a mean of all those salaries. Yeah, exactly. Shouldn't be too bad.
Okay, so let me pull up a calculator really quick.
Okay.
This is the first one. 61 and 8. So 16, so... Okay, so 1 second. Joe is ready to go ahead and join us, so I'm going to invite him.
$44,300. 44,300.
Okay. So I just invited Joe, so hopefully he'll join us here in just a second.
Okay.
Okay.
So divided by 5. So for that mean, if we are doing this right, what is the mean of your sample? So for my mean, I got 44,840.
Okay.
So I just went to all the numbers, added up the salaries, divided by 5.
You got 44,840?
Yeah.
Okay, cool. That's what I got.
Yeah, that's kind of weird because we can't check our answer.
Yeah. Okay, so this graph illustrates the sampling distribution of the sample mean. There are 142,506 possible combinations of the 30 salary count, drawn 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A.
Oh, okay. So I don't know how we would make a mark, but so the 46,000, our mean would fall right.
It wouldn't be unusual, right?
44,000.
No, it's within one. Looks like within one standard deviation of the mean.
Yeah.
Ooh. So yeah, basically we would just plot that right there at the 44,000 mark, just a little bit above 44,000.
Yeah. I mean, it would be if there's 3 hashes in each every 2, so it's going to be 44,500. It's going to be almost smack between the second or the first and second hash past 44.
Uh-huh. Wait a
Hi,
minute.
Joe.
How's it going?
Oh, I want to
Good,
meet
how are
Joe.
you?
Hey.
I'm doing good. Sorry, I'm just trying to pay attention to see where you guys are at right now. So,
Hey, what's up, man?
how's it going?
Dude, yo, I'm pretty sure we went to high school together.
Did we? Where'd you go to high school? IF?
Yeah,
What grade did you graduate? Or what year?
2011.
Okay, yeah, we did.
Oh, man, I've seen your face.
Last name?
That's funny.
What's that?
I said, what's your last name?
Fielding.
Fielding? As in
Yeah.
like Camden Fielding?
He's, well,
He's your
a grade
cousin?
younger. Yeah, he's like my cousin. He's a grade younger than us, right?
Yeah.
Yeah, man,
cool.
I remember your face.
Will do. Yes. Nice.
Okay.
Awesome.
Wait,
Anyway.
so when it's talking about if the sample mean appears to be unusual, how do you guys know the standard deviation of like all these of the distribution sample?
Um,
No.
well,
Because don't.
looking at how this is divided up, just guessing, it looks like it's every 2,000 is one standard deviation.
Mm-hmm.
Would be my guess. I'm trying to remember. I'm having a serious brain fart as far as finding a way to calculate that with what we're given.
Because it would make it unusual if it's more than 2 standard deviations away, right?
Yep.
Yeah. Well, that's what it's like.
Yeah.
Within that 44,000 range, if 46,000 is your mean, or just to the right of 46,000 is your mean, then
44,000.
within 44,000 is less than one standard deviation.
That makes sense.
Yeah. Really quick, Joe, to bring you up to speed.
Right.
Tyler and Naomi both are kind of limited on time, so we're just cruising through part 2 of the homework assignment, and then depending on how much time we have afterwards, we'll go back and talk about part 1. Through and do
Okay.
the
Yeah.
reading
I
and everything for
usually
this
just
assignment
do.
already.
I did do the reading. I had to go through it really fast. I didn't understand it super well, and so I'm hoping maybe you guys. I'm just gonna listen to you guys a little bit more.
Okay, sounds good.
Okay, no worries.
Yeah, I'll participate as much as I can though. So
Hey, that's all we ask.
Okay.
All right,
All
so. Okay, I am trying.
Drawn 5 at a time. This graph represents the distribution model. Hey, you know what else I figured out too today? Have you
What?
seen where it says like if you miss any problems on the assignment, refer to the video tutorials?
Yeah.
Have you
I
ever
haven't
watched
seen
those?
the video. I watched them for a couple of the lessons. I liked them.
Yeah, they're cool. If we're ever stumped as a group, we can always go over those, and that'll really help us out.
Okay.
Just throwing that out there.
It's a good throw.
Well, that's something almost more as like a one-on-one. You should do that. I don't know if that's something that we would do as a group or want to do as a group, or if that's something that we would rather do
Alone.
on our own.
Yeah, that makes sense.
Okay. So the standard deviation.
Does your sample appear to be unusual? Explain what you think it is. Or... So it's not unusual because it does not lie more than 2
So
standard
do we
deviations.
have? Do they give us a standard deviation for this one to start with?
That's what I was looking for. It doesn't look like it does, though.
Because I have a spot that on our assignment or in the reading, the standard deviation of the distribution of sample means, and it has a little tiny formula for it, but we need the standard deviation first.
Can we use that little... There's a sampling thing. Nope. That's weird.
What are you guys talking about standard deviation? It's just talking about the mean, isn't it?
No, because the mean is the center, and then the standard deviation is like the point from, or the distance between point A and point B. And so
Well,
that distance.
Supposed to look for the standard deviation?
What?
Are we supposed to look for the standard deviation? Are we supposed to figure that out?
Well, we need this. Well, in order to answer C correctly, like what be 100% correct on it,
Yeah.
we need to have the standard deviation. Although it does say, does it appear, and not is it? I would say no, it doesn't appear. Based off the information that we have, it appears to be within one standard deviation of the mean, which is usual or not unusual.
Yeah. And given the spread, I mean, it spreads from like pretty much 38,000 all the way up to 54,000. So that means the standard deviation is fairly large, right?
Yeah, well, I'm like looking at this. If 46,000 is going to be your center, we'll just say it's the center because it's the center most. Although from our curve, it's probably closer to like 46,500. The 44,000 is still okay. So 46,500 is our standard deviation, and we're at 44,840. And 2,000 is going to be our is one standard deviation. Then we're still within one standard deviation of the mean.
Yeah.
And
Okay.
so either way, looking at what we have here on this chart, either way I look at it, it looks like we're within one standard deviation.
Yeah, so it appears usual.
Yeah.
And that explanation pretty much sums it up, I would say. Yeah, that's weird. It didn't even give us like the full mean or anything.
Yeah. Who knows? I mean, if we were to go through and add all of those together, we could calculate our mean out and then go from there, but that would take a long time.
Yeah, true.
Okay, so 7. Oh gosh, come on. D. Compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice in practice? So this is something that we were supposed to do on our own and then talk about, it looks like.
Yeah.
Which I didn't do.
Yeah.
So that's something that we could, I mean, if you guys are staying a little bit later, we could always talk about or something.
Are these
If we move on to
are these numbers from the page right above it, where it
Yeah.
has like those where the numbers are from?
Yeah, so Tyler used, apparently in the reading there was a random number generator.
Okay.
And Tyler used it, and we got the numbers 16, 11, 8, 21, and 5. And so we took the values given with those numbers and calculated the mean, which is where we got 44,840. And that's where we're at. Then we just answered C. And then D is something, yeah, if we were to go and... That's something if we have enough time, because we got to get through the rest of this without Tyler, or with Tyler.
Yeah. And by the way, the link, if you guys want to do that, it's right above this chart. Where
Oh, really?
Says, cut out the squares. Yeah, where it says random.org/integers, right above the...
Oh.
Yeah, that's all I went to. That'll generate it for you.
So yeah, that might be something we could do a couple more times to see what type of answers we get, to compare it with what we have.
Yeah, that'd be good.
Okay.
Sweet.
Yeah, that's a good one, yeah.
Number 8, the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample, or N equals 10 students taking the GMAT. Okay. What is the shape of the distribution of the sample means for all such samples? So, in the reading, it talks about 2 different, you guys probably read about the law of large numbers, and then also the, like, let's see, what's it called? The central limit theorem.
The
Right.
chance that it's going to be... Oh, yeah.
Yeah, exactly. So what the central limit theorem says is that if there's, like, the larger the sample size, in this case, n equals 10, so that's not very large. One of 30 or plus, then we know that it is going to be normal. But since our sample size is 10, that rule doesn't really apply to it.
Okay.
So it says, what is the shape of the distribution of the sample means for all such samples? It could be not normal just because the sample size is so small.
Okay.
Okay.
That's what I think.
So with this, just kind of like the central limit theorem, we can say, so if we had a sample size of like 31, we could say that the sample shape would be normal.
Yeah.
Is that right?
Mm-hmm.
Okay.
30 or above, that's like the rule. Let me double check on that though.
I
But,
think it
yeah,
said
that's
N
what I would
equals
say.
40. I mean,
Not
I only
normal.
saw 45. I didn't see 30. Yeah.
Really? Yeah, I could probably double check on that one too.
Yeah.
What's that looking here?
Yeah, I think it said 45. I didn't see 30 in there anywhere.
Let's
I
see.
don't know. I might be looking at a different place, but
Oh, okay. Yeah, so it says for this course, if n is greater than or equal to 30, we will say the distribution of the sample means will be approximately normal.
Okay.
Okay.
Where are you seeing that in the reading?
That's lesson 6. It's like towards the end, right? Where you're looking at?
Yeah. Yeah, it's like right above the summary in like the second bullet
Oh,
point.
okay, I see it. Yeah, that last bullet on 2.1.
Yeah, exactly.
Okay.
So,
okay.
I hope it's asking this question right. How do you know that the distribution of the sample mean has this shape? But I guess it is asking for the shape. So I think we'd have to give it a description like, so it wouldn't be bell-shaped or symmetrical. It'd either be like skewed or uniform or something.
Mm-hmm.
Or I guess not uniform. It'd probably be skewed. I
Skewed
think it
left,
would be right skewed.
right skewed?
Yeah, right or left skewed.
Is that considered a shape? Where
I think-
does
I think so,
Oh,
just
okay.
from
Okay.
one of our previous lessons.
Yeah, that makes sense. There's also the examples where it had like different peaks, because like in the bell curve there's one main peak and it all kind of builds up to it. But there's also times where there's like two different peaks, and they had a name for that one. I forgot what it was called, but
That's true, that's true.
when there's like not enough, or when it's just uneven.
Yeah,
Yeah, right there.
I would say right skewed.
Okay.
Okay.
Because I was messing with did you guys get the chance to mess with the little simulator from the lesson?
Mm-mm.
A little bit, but not much.
Though, whenever the sample size was super small, it was always right skewed.
So the right size was bigger, right?
Or when it's right side, the left side is bigger, and then the right side has like that big tail.
Okay.
To the right.
Right, that's a right skewed. Okay. Okay. So
How do you know that the distribution of this the shape?
it would be right skewed. Yeah. Okay. How do you know that the distribution of the sample mean has this shape? I think you pretty well explained that in with saying that because the sampling is so small.
Yeah, that would be the answer. Because the sample size is smaller than 30.
Right. Okay. What is the mean of the sampling distribution of sample mean scores for all such samples?
Oh, this one's awesome.
I have no idea what that's supposed to mean.
It's super easy. It's just 529.
Oh, really?
It's just the mean of everything?
Yeah, it's one of the rules. Like, yeah, you'll do a bunch of it in part 1. That one's super easy.
Okay. And then our last question. What was the standard deviation of the sampling? So is this the same deal where it's just the standard deviation of everything?
This one, we take the standard deviation and we divide it by the square root of 10, which is the sampling
that's right.
size.
I saw that. So we would take the 113 And then divided by
square root of 10.
35.734.
Is that what you got?
Yeah, 35.7.
Square roots on my calculator. Square root. Wait, so what was it? Sorry?
35.
I got 5.734.
Yep, okay.
0.734. Awesome, awesome. Should we check our answers on this real quick?
Yeah.
Can't hurt, right?
Okay, so there's all of part ones.
Let's see. Do you have to get going soon, Tyler?
Yeah, I should be okay. We can just spend most of the next little bit just on the quiz. Ah, dang it.
Okay.
I failed us, team. I failed us on A and B.
How can it be normally distributed? Let's see.
There was two rules to it. I completely forgot that other rule. The first rule just says
Yeah.
if
What's the other
sample
rule?
size is large, then it's normal, but also if the parent population is normally distributed, which, how do you know if the parent population is normally distributed?
Well,
Population is greater than base.
in the thing it says the scores in the GMAT are normally distributed, so
Oh,
would that be
dang
it?
it. Okay, then it should have been.
That's good to know
Okay,
that we
that makes sense.
Mhm.
My bad, team.
Cool.
No worries.
It's okay.
Well, we got everything else good.
Yeah,
Okay.
I think we did good. All right,
So
should we
you want-
take this quiz?
Sure. Let's jump in and do it.
I'm so excited.
Yeah, I don't think these things actually count towards our score anyway, so...
Yeah, they're pretty minor on points.
Yeah.
Mhm.
And I remember that one time we all put the same answers, but I got like a
That was weird.
Yeah,
You had a ridiculously low score for no reason.
I emailed her about it. I think she changed it, but even with the bad score, it didn't hardly change my grade.
I don't think that these have any effect on our grade, honestly.
I love them. They're so fun.
All right, so hit start and let's go.
All right.
Go team, save money.
Bum, bum, bum. Okay, so when taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? Whoa.
Would that mean that it's also going to be right skewed?
That's what I'm wondering.
Let me check. This could be from the simulator on our reading.
Yeah, that's what I think so. It looks like it.
So it says, I have the simulator all pulled up. When taking samples of n when n equals 5, what was the shape of the distributions of means histogram when the parent population is right skewed? Yeah, so we just go to the simulator and we hit skewed. Oh, mine's all messed up. Let me pull that thing up again. So we go to skewed, and then we change n to 5, and then we can animate it a little bit. And then we can do a ton of samples, 10,100. Ooh, that's weird.
What?
It kind of looks right skewed, but it also looks pretty normal.
Yeah. Well, mine comes out as a low or a. Okay, no, that's right skewed.
Did you see it? Have you seen it?
I'm trying to get to load. It's not wanting to work with me.
I'm almost positive. Actually, I am positive that it's not normal, though, because it goes against both of those rules. That if it's normal, the only way it can be normal is if the parent population is normal and if the sample size is higher than 5.
Right.
And considering the fact that none of those happened, I'm pretty sure it's skewed right.
Mhm.
Okay.
Yeah, I'm pretty sure. That makes sense.
Yeah, it looks like it doesn't look very skewed, but it is a little skewed, right?
Yeah.
And you can tell the left side comes up pretty sharply compared to what the right side does.
Yeah, that's true.
Okay, so I want to take a sample size of n equals 100. What was the shape of the distribution of means histogram when the parent population is skewed right? Or is right skewed?
Well, it's going to be normal because the sample size is above 30.
Mm-hmm.
And it doesn't even give us that option on the simulator, which is
I just
weird.
did it a bunch of times. There you go. Okay.
It should be normal, though.
Yeah. Looks
Yeah,
pretty.
mine's super normal. And whenever the sampling size is that high, the standard deviation is super little, so the shape is like super skinny and tall. It's pretty cool.
Right. Okay. So number 6, what would the distribution of means be normally or when would the distribution of means be normally distributed? Choose all correct answers. So data drawn from a population that is normally distributed and the sample size is small.
Mm-hmm.
So would that one be normally distributed?
I think so, yeah.
I think
'Cause
it's
that's how.
all of them except for data. Oh gosh, just the way that this is worded kills me a little bit. Data are
No.
drawn from a population that is right skewed and the sample size is small.
Yeah, that's what I'd say too.
I think all the other ones are right based off of what I've gathered from this meeting.
I think so too.
Okay. So, which of the following gives the best explanation of the central limit theorem?
Central limit theorem points all the way to being a more normal shape. So if the parent population, that one's not it, that one's not it. Sample size is large, the sample mean will be close to the population mean. Sample size is large, the shape of the sample mean. That one.
Which one is it?
I have the, if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. But if the sample size is large, the sample mean will be close. Oh no, just kidding. Yeah, so it's the one that ends with the sample mean will be approximately normal.
Yeah, I just
The
read that in the read.
Yeah. The other one, if the sample size is large, the sample mean will be close to the population mean. That one's talking about the law of large numbers.
So it's the one you thought?
Yeah.
Okay. Cool.
The XP random variable with population.
So in the XP random variable, the population mean mu equals 10, and population standard deviation, I don't even remember, equals 6. Suppose a sample size of n, 36 is drawn from this population, so the mean of the distribution is still going to be 10, right?
Yep.
Okay.
And then for 9, we just have to take 6 divided by the square root of 36.
Right.
Still there?
Can you hear me?
Yeah?
One.
Yeah, I can hear you now a little bit.
The square root of 36 is 6, and then 6 divided by 6 is 1. That's weird that it says 3 decimal places. They're trying to throw us off.
Yeah.
Wait, don't you take
Yeah.
n over the standard deviation, or the square root of the standard deviation, or is it
How's it going?
the standard deviation over the square root of n?
It's the standard deviation over the square root of n.
Okay.
I'll double check that though, because that would be a weird mistake that I could make. What the? Where'd that go? Yeah.
Okay, I've got. Okay, standard deviation over square root. Okay, cool. So then 10, regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would the shape of the distribution, or what would be the shape of the distribution of the sample mean? So regardless of the distribution of the population, since our sample size is large, it's going to be normal, right?
Yep.
And
And
that's based off.
that's like that's not a law or anything in statistics. All it said is that that's a good rule of thumb to go by for this course.
Right. Well, was that in like the law of large numbers or the central limit theorem?
That has to do with that I
Or
don't think it
central-
has to do with any of those rules. It's just mostly for determining like the shape of a
Well,
distribution. I guess kind of
11
the central limit theorem.
Okay, yeah. 11 asks what theorem would justify. It even says theorem.
Actually, I was leaning towards.
Ooh, that's cool.
I'm thinking it's the law of large numbers.
So since it says regardless of the distribution of the population, it's all asking like about the shape. The central limit theorem is all about the shape of it's all about having the shape become more normal, whereas the law of large numbers is all about having the sample mean population come closer to the population mean.
Well, the sample mean closer to the standard deviation, or yeah, to the.
Yeah, the sample mean to the population mean.
Okay.
The law of large numbers is all based on how accurate it is, whereas central limit theorem is all based on how normal the shape is.
Okay.
Okay.
I would think it's central limit.
I think you're right. All
We
right.
should do this thing.
You guys ready for this?
Let's do it.
1 second. Can we go over everything? I think I was missing actually a good portion of that. Do you mind if we went over those? I've got one. Yeah, let's see. I've got 7 and 10 and 11 and 3, and I've actually missed everything else. So.
Okay. We can go over it with him, Tyler, if you need to take off.
Hey, we got 100.
Woo.
Okay, yeah, I might need to take off.
Okay, go for it. I'll
Okay.
go over. Okay, so the first two, Joe, are
Okay.
based off of, so number one is based off of what you did before we met as a group. And so that's just an answered for yourself type of thing.
Okay.
And then number two is just asking if you participated while you were in our group. So those ones are really kind of pretty simple as far as...
Yeah. I'm just
Yeah.
looking at like
See
4
you
and 5 and 6.
Hi.
You see, man, appreciate it.
And then what was the first one you missed?
The first one I missed was 4, and I missed 5 and 6.
So 4, 5, and 6 we need to go over again?
Yeah.
Okay. So when taking samples of n equals 100, what was the shape of the distribution means histogram when the parent population is right skewed? So in the reading, kind of towards the top of it, it gave
Okay.
the link for at 1.1 in the reading. It gave the link to go to that histogram generator.
Okay.
So you go in there, you change it to a skewed, and then you take n equals 100, so you have 100 samples of the means, and it comes out looking pretty normal. And so our answer for 4 was normal.
Okay.
And then
Interesting. All right.
for 5, when taking samples of n equals 100, because this n equals 100 falls within the greater than 30 of the central limit theorem, and then the population is normally distributed, we decided that one would just turn out normal by itself.
Okay.
And then when would the distribution of means be normally distributed on 6? We did more of a process of elimination and said, well, the only one that this wouldn't come out to be normal with is the one that says data are drawn from a population that is right skewed and the sample size is small.
Okay. That one does make sense.
So you
That
would
one I get. I
check.
mean, that's pretty simple. 4 and 5 are a
Yeah.
little bit different too. Man, have to mess around with everything a little bit.
So number 6, you would want to check the other 3 because it's asking you to check all correct responses. And
Oh,
so
really?
just that one you would leave unchecked. And then did you miss anything else?
Yeah, I missed. Let's see. No, now for number 6, it was just the third one. Is that what you said?
Yeah.
Yeah, you don't. So number 6, don't check the third. Check 1, 2, and 4.
Oh, really?
Leave the third one blank because it's asking for correct responses, and you can have more than one.
Oh, yeah. Okay, gotcha. All right, sounds good. Now number 8 then. So what is the mean of the distribution of sample means? Like I kind of pretty much didn't get what was a sample mean, and so like that was kind of a tough one actually.
So the sample mean, and this is one Tyler just kind of told us, like the sample mean is 10, and so the mean of the sample means, I guess for all intents and purposes up to this point, is also going to be 10.
Okay.
And so the answer is just 10. And then the standard deviation of the distribution of sample means, you take the standard deviation, so 6, and then divide it by the square root of n.
Which is 36.
Yeah.
So
and
it would just be. Yeah, go ahead.
Well, because of that, it comes out to 1.
And you have to put it to 3 decimal places, so you just 1.000 is what you put.
I just put
Well,
1.
Yeah.
And it worked.
A lot of times. Go for it, Naomi.
Oh, I just put 1 and it worked. I got 100.
Mm-hmm. Okay.
Okay.
That's
A
good.
lot of the times, if the last decimal place is 0, and you can leave that off, so where our last 3 would be 0, that's not a problem.
Okay. Sounds good.
Um,
Yeah, I appreciate it. So that's all of them. I got 10 and 11. 10 is normal, 11 is central limit is what we had, right?
Yeah.
Okay,
Yep.
perfect. All right. I did not. Yeah, I'm assuming not. I will not get 100, just because I didn't have time to complete everything beforehand. But yeah. All right.
That's
Well,
cool. Same here.
sweet. Appreciate it. Thanks for the help, guys.
Okay, so
Mm-hmm.
Tyler, or wow, Joe.
Yeah.
Our meetings we try to do Tuesdays and Thursdays at 5 o'clock,
All right.
roughly. So just going forward, that's what we plan for. But life happens, like today, and so we try to be as flexible as possible.
Yeah. Okay.
But we need to have these in. So Naomi, I'll send you the link for this, or I'll just post it myself because
Okay.
you're busy here in like 5 minutes.
Yeah.
We
Sounds
have
good.
these in before
You're going to post it?
11:55. What?
Okay, you're posting it?
Yeah, I'll post it.
Okay.
Cool.
All right.
Do you have any other questions, Joe?
No, that's all I got. Appreciate it.
Awesome. Then I'll see you guys on Thursday. Thanks.
All right.
Alrighty.
Thank you.
Yeah, we'll see you guys.